Hello everyone and welcome to day 2 of the logarithm unit. Just as a reminder of what we did last class, if we look at this idea of log of 5 of base 5 of 25 equals x. What are we looking at here? And as what I said is that the logs give you the exponent. And so the thing that we have to remember here is that the base, we have to think to ourselves 5, bad color, 5 to what power equals 25, or in this case, because we know it equals x, we can put an x in there. So 5 to the x power equals 25. So what does that mean? That x has to be 2. We know 5 squared will give you 25. So that's the idea of logs. Remember that logs are the inverses of exponential functions. And so we have 5 to the x power equals 25, and we can figure that out from there. To move on here, we have the product, quotient, and power rule for exponents. And we know that when we have b to the x times b to the y, we know that's b to the x plus y. b to the x divided by b to the y, we know that we subtract exponents. And when we have a power to a power, we multiply exponents. It's the same idea. Since they're in logarithms or inverses of exponents, we know that we can use the same rules. So if we have log base b of x times y, we can rewrite it as log base b of x plus log base b of y because it's a multiplication. Here we see division, so we can write it as subtraction. And here, when we have a power, we write it as multiplication. What that means is that that power can come out in front. So it's y times log base b of x. One thing that you cannot do is if I gave you log base c of 3x, this does not equal log base c of 3 plus x. This is not the case. You need to keep the logs with each portion. So just like we keep the bases here, you have to keep the log base portion with each of the variables. So that's key. It's always log base b plus log base b minus log base b. So that's one of the things you do not want to mess up. So let's look at a couple examples here. Today is only 2 pages worth of notes, so that's better than yesterday's or the previous lessons of 4 pages. So let's look at this. Log base 3 of 9 times x. It's multiplication. So we know we're going to rewrite that as log base 3 of 9 plus, because it's multiplication, log base 3 of x. Now, I talked about it at the very beginning. We have to look at it. It has to become standard. It has to become just memory that when we say log base 3 of 9, we think to ourselves 3 to what power equals 9. And we know that that 3 squared equals 9. So we're going to say 2 plus log base 3 of x. We can simplify that portion of it by thinking to ourselves 3 to what power gives you 9. So we look over at the multiple choice. 2 plus log base 3 of x is choice 3. Notice that I didn't even look at the multiple choice first. I went and did the problem and then looked at the multiple choice. We don't ever want to look at the multiple choice first with these. So let's look at this. We got log base x squared divided by 1000. We see the division, so we automatically think subtraction. So log of x squared minus log of 1000. Now in the previous lesson I talked about this, is that when we don't see a log, we think it's a common log. The common log is this idea that it's log base 10. Now in this case, we know that 10 to some power can't ever equal x squared, so we're going to leave it as log of x squared. But with this one we can. 10 to what power gives you 1000? Well, we know it's 10 to the third. And so we know that that's just going to be minus 3. One of the other things that you can do in your calculator is just put log of 1000 to give you the answer. If you don't have a base 10, you can put in that. But just think about 10 to what power? How many times you have to multiply 10 to get 1,000. 10 times 10 gives you 100. Then times 10 gives you 1,000. That's why it's 3. The last portion that we need to remember here is that we have an exponent, and that's called the power rule. When we have an exponent, the power rule tells us that we can bring it out in front. So we're left with 2 log of x minus 3. And I should be putting equal signs here. Do we have an example that says 2 log of x minus 3? We do. Choice 1. So in this case, we had 3 things that we had to remember. Subtract because it's division. We had to think 10 to what power gives you 1,000. And we had the power rule that says the 2 comes out in front because power, you multiply the exponents and the 2 can come out in front to be 2 times that. In example 3, we're going to get a different idea here. One that sometimes we struggle with. The idea that when we want to put log 3 and log 2 in terms or express it as the value of log 12. So when I see these, and I know I have to go 12, log of 12, and I have to get the number 12 to be represented by 2 and 3, I think 12 equals what? Well, you can do it a couple ways. If you just know it, you can say, well, 12 could be 3 times 4. Well, 4 is not one of these examples, so I could go and break 4 into 2 times 2. But you can also do this idea of a prime branch, prime factorization. So 12 can be 4 and 3, and then I can keep breaking. 3 can only go into 3 and 1, so we don't mind that. 4 can break into 2 and 2. And notice that since we're looking for numbers of 2 and 3, this is what I have. So since I have that 12 can be represented by the numbers of 3 and 2 by doing 3 times 2 times 2. That's important to have. So now let's look at what we could rewrite it as. Log 12 equals log of 3 times 2 times 2. Oh, well, we see multiplication. This must be the product rule. So I can rewrite this as log, or, before I go on, know that you could rewrite 2 times 2 as 2 squared. So I can rewrite this as log of 3 plus log of 2 squared. Well, I'm almost done. There's nothing I can do with log of 3, but I can bring this 2, doing the power rule, out in front. So I can rewrite it as log of 3 plus 2 log of 2. And the final step is to notice that log of 3 is a, so this is a, and log of 2 is b, so I have a plus 2b. And do I have an a plus 2b here? I do. It's choice 4. So again, the idea when we see a number and we have to represent it in terms of a or b or whatever variable they give you, we have to look at what number is represented by that. We have a 3 and a 2, and how do we break up 12 to give you only the values of 3 and 2? So 3 times 2 times 2. Moving on to exercise 4. Log base 2 of square root of x divided by y to the 5th. So as soon as I see this, I notice that we have the quotient rule. And how else can I write square root of x? I don't have any numbers with square root of x, but I know I can't leave it as square root of x. Notice it, besides this one, which would be wrong. So I can rewrite a square root, we talked about this before, as x to the 1/2. So I'm going to redo the quotient rule first. Log base 2 of x to the 1/2 minus log base 2 of y to the 5th. So I did the quotient rule first. The next thing that I notice here is that I have powers. I have exponents. When I have a power, I'm going to use the power rule. So I'm going to bring the exponents out in front due to the fact that it's multiplication. So 1/2 log base 2 of x minus 5 log base 2 of y. And do any of these look like that? Well, let's see here. 1/2 log base 2 of x, well, there's the 1/2, minus 5 log base 2 of y. Yep, there it is, choice 3. So again, you're looking at it. What do you notice out of these rules that we have here? And how can I then, quote, expand it? Exercise 5. I have log base 3, and notice here that I have just numbers. I don't even have variables. So I'm going to immediately notice that this is 5 to the 1/2, and I have the quotient rule right there. So I'm going to rewrite it. Log base 3 of 5 to the 1/2 subtracted from log base 3 of 27. Well, immediately I'm going to notice that this 1/2 can come out in front due to the power rule. And here I notice that I have two numbers. So I'm going to think to myself, 3 to what power gives you 27? Well, 3 squared gives you 9. 9 times 3 is 27, so this is going to be 3. So I can finish rewriting this as minus 3. Done. Notice that there's nothing more I can do here. 3 to what power gives you 5? There isn't any. Well, there is one. It's not a nice whole number, so we're not going to worry about it when we're expanding. So we look here and it says which one's equal to that? Well, 2 log base 3, no. 2, nope, we know it's 1/2. So we know it must be 1 or 3. Notice that this division is over both the log base 3 of 5 and the other number. If I need it to be equivalent to 3, 3 divided by 2 is not 3. 6 divided by 2 is. And so therefore that's why it must be choice 1. Notice that 3 divided by 2 is not equivalent to 3. It's finding a common denominator, and so that's why you have to multiply 3 by 2. Let's see here. 6. F of g of x. We're looking at a composition. So I'm taking what g of x is and I'm plugging it in for x. So I can say f of g of x equals log of 100x cubed, because that 100x cubed is going to replace the x that's in for f of x. So 100x cubed. I notice that it's multiplication, so I immediately say log of 100 plus log of x cubed. I then say, oh, I remember that this had to deal with 100s, 1000s. You could do something with that. So I remember that it's log base 10. When there's nothing there, it's a common logarithm. 10 to what power equals 100? I know this is 2. And then I also remember here that I have an exponent. It can be brought out in front using the power rule. So I'm going to have 2 plus 3 log x. Oh, it's right there, choice 4. Moving on to the last two examples here. Now, exercise 7. I notice here that I have a square root over the entire thing. So I can rewrite this as log base 2 of 32x 7, all raised to the 1/2. So notice that this is an immediate power rule because it's raised everything, even though there's multiplication here. So let me start that again. Even though there's multiplication on the inside, you notice that it's all raised to the 1/2. That means that I'm going to take this 1/2 and I'm going to bring it out in front to begin with. Now, the only issue with doing this is sometimes people forget that the 1/2 is out in front and don't carry it to both of them. But I like to get this 1/2 out in front. Now I have log base 2 of 32x to the 7th. And you know it's multiplication. So what I'm going to do here is I'm going to rewrite this as the product rule, adding them. But what I can't forget is that there's a 1/2 out in front. So I'm going to have 1/2 log base 2 of 32 plus 1/2 log base 2 of x to the 7th. Now I notice that these are only numbers here. Notice that this is only numbers right here. So I'm going to think to myself, 2 to what power gives you 32? Well, 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. So I know this is 1/2 times 5. I know power rule here because x to the 7th can come out, so 7/2 log base 2 of x. Now, which one is equivalent to this? Well, I'm looking, this is 5 divided by 2. Well, can't be any of those. 5 divided by 2 is right here, and 7 divided by 2 is right there with a log base 2 of x, so I know it must be choice 2. Exercise 8, what I would really like you guys to do right now is pause it and see if you can get exercise 8. Try it on your own. Me doing this for you and you guys not thinking, I would really like you guys to think. So try exercise 8 and then I'll finish with exercise 9. So this was a tricky one, I know that. I wanted you guys to try to think about it. And what I did here, so maybe if you got it, great, you can skip on to the next problem. If you didn't get it, I'll go through my thinking. 49, and I'm given 7. How do I get 49 into just be 7? Well, I know 7 times 7 gives me 49, but I'm still left with this idea that it's 49 times 100. Well, again, logarithms are always about the common base 10. So can I get 100 into be 10? And maybe I can work with that. So I know that's 10 times 10. So I rewrote it as 7 times 7 times 10 times 10. So the 7 was given to us. We knew we had to get it in terms of 7. And then the 10s are given because it's a common base. So I can rewrite this as log of 7 squared plus log of 10 squared. I can bring the 2 out in front to be 2 log of 7. And I can also bring this 2 out in front to give us log of 10. Well, log of 10 is 10 to what power is 10? And it's to the first power. And so this is really, log of 10 is just going to be 1. So I know it's, when I bring the 2 out in front, I get 2 times log of 10, which is 1. I can factor the 2's out. I need to do that. Log of 7 is equivalent to k, so I'm going to get 2k, 2 parentheses, k plus 1. Now for the very last problem, it would like you to rewrite this. So I'm going to go slow. I want you guys to try this. Maybe not listen to me here. We're going to rewrite this. Log base 2 of 8 to the x. Well, I know this x is a power, so it can come out in front. So now that's equivalent to x log base 2 of 8. I notice that 2 and 8 are numbers. So I think, does this work? 2 to what power gives me 8 cubed? So I know this is equivalent to x times 3, since the 3 is the exponent, which we don't ever write it as x times 3, we just write it as 3x. So that's what it is equivalent to, or in the simplified version. For b, it wants to test it. I'm not going to do 0, 1, and 2, but I'll work with you on 0 and 1. It wants to test it, so we're going to do log base 2 of 8 to the x on one side and 3 times x on the other. And let's test it for x equals 0. Log base 2 of 8 to the 0 and 3 times 0. Well, we know that's just 0. Let's think of this. Anything to the 0 power is 1. So we know that's equivalent to log base 2 of 1. And when I think of it, 2 to what power will give me 1? Anything raised to an exponent raised to the 0 power will always equal 1. So yes, that is equivalent. 0. Okay, this will give you 0, the exponent is 0, and 3 times 0 is 0. Oh, that works. And of course, let's hope it works on this one. Log base 2 of 8 to the first. Okay, this equals log base 2 of 8. Well, let's think of this. 2 to what power will give you 8? Well, we already did that over there. That's 3. And 3 times 1 is 3. And so it does work. And it would work for 2 also. The last part is showing that log base 2 of 8 to the x equals 3x by rewriting 8 as 2 cubed. So log base 2 of 2 cubed because it says to rewrite 8 as 2 cubed, raised to the x equals 3x. Well, you have a power here. Where does it go? It goes out in front. So x log base 2 of 2 cubed equals 3x. Now, this is important to see, and I'm surprised we didn't get to it beforehand. What this is talking about, maybe I'll come down here. When I have log base 2 of 2 to the third, this is the same thing as saying 2 to what power equals 2 cubed. And when you see this, well, if this is 2, we have the same bases, the exponents must be the same, and so that must equal 3. And so therefore, if this whole thing equals 3, we have 3x equals 3x, and it works. But the idea here is that when you have the base and the base of the of portion the same, it must be equivalent to the exponent. Same idea, let's try one here. Log base a of a to the z equals, well, this is saying a to what power equals a to the z. Again, it must equal what that exponent is. The same idea as if I ever have log base a of 1, a to what power will equal 1, well, I know it must be 0. So if I ever have a 1 as the of portion of it, I know that has to equal 0. So that's it for today. Those are the properties of exponents, or of logarithms, excuse me, and exponents, but property of logarithms, knowing that the product, the quotient, the power rule, we call it, and then having to see that when you have two numbers as the base and of the of portion, that you can sometimes, not always, but sometimes easily simplify it to a whole integer. So with that, enjoy your day, and if you have any questions, please email us as your teachers. We will do our best to help you.